Hey, smart people. Have you ever wondered why glass is clear? I mean, it's a solid, right? Bricks are solid. Steel is solid, but you can't see through them. So what makes glass so special? If you look at an atom, it's mostly empty space, a tiny nucleus with a cloud of electrons whizzing around. So why doesn't light just pass through everything? Why aren't we transparent? Well, in a way, we are to X-rays, at least. Our bodies aren't transparent to visible light. The secret lies in energy. Think of electrons in an atom like they're living on different floors of a building. These are called energy levels. To jump to a higher floor, an electron needs a photon of light to come along with the perfect amount of energy. Not too little, not too much. It has to be just right. If the photon's energy doesn't match, it just passes straight through. Now, let's talk about glass. Glass is mostly made of silicon and oxygen atoms. Just like sand, when sand is melted and cooled down fast, its atoms get frozen in a jumbled, random structure. For the atoms in glass, the energy levels the floors of the building are really far apart. The photons of visible light just do. You won't have enough energy to boost those electrons to the next level. So, visible light just zips right through. That's why glass is clear. But what about ultraviolet light, or UV light? Those photons have more energy. In fact, they have the perfect amount of energy to get those electrons in glass to jump up. So, glass absorbs UV light. This is why it is hard to get a sunburn through a window, whether something is transparent or opaque. All comes down to this relationship between the energy of light and the energy levels of electrons in its atoms. Different materials have different energy requirements. When visible light hits my skin, for example, my atoms absorb it. That's why I'm opaque. But higher energy X-rays can pass right through me. This idea of atoms being mostly empty space brings up another question. If my feet are mostly empty space, and the floor is mostly empty space, why don't I just fall right through the earth? Why can't I touch things? When I go to touch something, say, my hand to this table, our atoms get super close. The electrons surrounding my atoms are negatively charged, and so are the electrons in the table's atoms. As they approach each other, these negative charges push back. They repel each other. This is called electrostatic repulsion. What you feel as touch is actually this repulsive force pushing against the nerves in your skin. You're not actually making contact you're just getting as close as physics will allow before the electrons start saying, hey, back off. It's this fundamental force that stops you from falling through your chair and allows you to interact with the world. So, from the see-through nature of glass to the very sensation of touch, it all comes down to the fascinating quantum world of electrons and energy. It's the reason the photons making this video can pass through my camera lens, travel through fiber optic cables, and shine through your screen, making this little bit of science just a little bit clearer. Thanks for watching, and stay curious.